Okay, we're talking about properties of inequalities here. This usually follows under some type of theorem. We're not going to be doing any of the proofs on this, proving any of this, but we'll just work some examples and we'll just take it for granted that these statements are true. Okay, so we have A and B are real numbers, and the way this statement reads is it says if A is less than B and B is less than C, then A must be less than C. If we just draw up a real number line here and maybe just do an example. Of course, I know you're probably going, wait a minute, that's trivial. We'll let that be the origin. We'll say that this is A, and we'll say that this is B, this point here on the real number line. And we'll say that's C right there. So as you can see, A is left of B, therefore A must be less than C. B is to the left of C, therefore we can conclude now that A must be less than C. I know that sounds really trivial, but we got to really look at this in detail. Okay, let's look at another property. Okay, we have in this particular case here, we've got A is less than B, C is less than D, then A plus C must be less than B plus D. Does that sound obvious? Let's just give this some let's give these guys some numbers here. So let's say A is 2 and B, let's say, is 6. So 2 is less than 6, and C we'll give that we'll say that's 1, and we'll say that D we'll give that 10. Okay, so this is my A, this is my B, C, and D. Then it must follow that A plus C, so that would be 2 plus 1, should be less than B plus D, which is 6 plus 10. And of course that's 3 is less than 16. Now this is one particular case right here to to show this for all real numbers. Well, we'd have to prove this, and this proof is real. I guess I can go through the proof here on this. What I'm going to do is we said that I'll just write this out. We said that A was less than B, and then up underneath this I'm going to write B is less than C. And then what I'm going to do here is I'm going to add these together, so we'd have A plus B, would that be less than B plus C? But that's not exactly what I've got written. Oh, it's supposed to be D there, sorry. B plus D. And that's supposed to be C. We kind of messed that up. Okay. So we have A plus C is less than B plus D, and that's what we had in the conclusion of our statement. I wasn't paying attention when I wrote this stuff down. Let's look at another one. Okay, we have A is less than B. K is any element of R. Then we could say that A plus K is less than B plus K. And I think that's kind of obvious there. We can do some examples. For example, we'll say A is 2. That's less than, let's say 20. K is any real number. Let's let K equal -1. How's that? So we ended up with 2 minus 1 is less than 20 minus 1. So as you can see here then that this would be 1, which is less than 19. Alright, let's look at some others. Kind of quickly here, I'm just going to mention this, not working examples on this. We have A less than B and K is greater than 0, then AK is less than BK. Okay, so basically what we're doing here is we are just multiplying both sides by K. Okay, and this is K is greater than 0. Now watch what happens if K is less than 0. In other words, it's a negative number. Now this is the rule that a lot of people forget, and that is, if you notice in this particular one here, that the inequality has been flipped. Okay, it's been flipped around. If you multiply both sides by a negative number, okay, K is less than 0, then we have to flip this symbol, the inequality here. It's got to be flipped. So we're going to say K is negative, so therefore we'll have to flip it, and that's usually something that people forget to do, and that's flip this inequality. And they also say, well, if you divide both sides by a negative, you also have to flip the inequality. So remember that you must flip the inequality if you multiply both sides by a negative number.